Now, we finalize this by looking at some shapes in spherical coordinates. What does it mean to say rho is equal to, let's say, 5? 5 is equal to pi on 7. Let me say pi on 4. And let's say theta is equal to pi on 6. Now let me start. Rho equal to pi on 5. Rho is equal to 5. It means that I have not defined theta, I have not defined phi. Let me clean it. It means that the distance from the origin is 5. It doesn't care which direction it goes. Right? So here I can measure 5 and it will give me a circle here. Also measure another 5 and it will go. So actually it's the sphere of radius 5. Do you follow? If I measure distance 5, I can go in any direction. Right? I can go this way and also go that way. Okay, all 5, whatever it is, 5. So it's a sphere of radius 5. Next, I look at phi is equal to pi on, let's say, 3. Phi is equal to pi on 3. Says the angle, our projected line from our origin mixed with this is pi on 3. Right, now it can go in any direction. And it's still what? Pi on 3. Pi on 3. So this is a cone which makes angle pi on 3 with z. I don't know whether you understood me. But a moment. You see, if this, you can't see. Wow. Okay. Look at the corner here, right? If a moment. If this is my z, right? There's my z, okay? And how do I make it stand? Okay, stand. And this is my rho, right? And it's making the angle pi. Let me see. What? If this makes the angle pi on 3, right? Now it can go round, still pi on 3, still pi on 3. You get it? It can go round, and it's still what? Pi on 3. So it's going round, it's not changing, right? And it will become a cone. It becomes a cone. it becomes a cone of radius pi, sorry, a cone that makes an angle pi on 3, right, with our z. Okay. We also look at when theta is equal to pi on 4. And this is just like what we saw in cylindrical coordinates. It's going to be a plane that means an angle pi on 4 with the z. Okay, let me go back to your slides and see whether I can get a question. Now, example 2 says identify the surfaces for each of the following. We've seen what it means when we say rho is equal to 5, right? We said this as a sphere of radius 5. We've seen what it is for 5 to be equal to pi on 3 and theta 2 over 3 pi. Now what we've not seen is rho sine 5 is equal to 2. Okay, rho sine 5 is equal to 2. We want to identify the surface. Now how do I do that? We have 2 ways. Remember, rho sine 5 we say is equal to r, and r is equal to 2. So it means that I have converted this one from spherical to cylindrical. And in cylindrical, r is equal to 2 as a cylinder of radius 2 centered at the origin. But we can still make this more interesting. Okay, we can square both sides. If we square both sides, we have r rho squared sine squared 5 is equal to 4. Rho squared sine squared 5 is equal to 4. And next, we can decide to add rho squared. Okay, you see. Let's see. Rho squared sine squared 5 plus rho squared cos squared 5 is equal to 4 plus rho squared cos squared 5. Now, if we add rho squared cos squared 5 to both sides, right? And factorize rho out from here. Okay, I'm going to have rho squared out, sine squared 5 plus cos squared 5 is equal to 4 plus rho squared cos squared 5. Now, this and that is 1. So I have rho squared is equal to 4 plus rho squared cos squared 5. Now, what do I see here? Rho squared, right, is s squared plus y squared plus z squared. Remember, is equal to 4 plus rho squared sine squared 5 is z squared. All squared is z squared, right? Now z to subtract z squared will cancel. So I have s squared plus y squared is equal to 4. And this is a cylinder of radius 2 in rectangular coordinates. We've had enough of coordinate systems. Let's move on to multiple integral, precisely double integral.